A spontaneous process is one that occurs on its own without any outside assistance. And as an example, this would be something like if you dropped an egg, that egg will break when it hits the ground. Or if you leave a nail outside, eventually it will rust. You don't have to do anything. The egg will break on its own automatically. The nail will rust automatically. You don't have to put any effort into those things. And these spontaneous processes are only spontaneous in one direction. They're non-spontaneous in the other direction. And so, using the same examples, a broken egg won't spontaneously reform, or rusty nails don't spontaneously unrust. And spontaneous processes are going to be affected by environmental conditions. So these spontaneous processes are affected by things like the temperature or the pressure of the surroundings. And with an easy example, consider something like ice melting. At 20 degrees Celsius, ice melts spontaneously. But that exact same process, solid ice converting into liquid water, is not spontaneous at negative temperatures. So, say minus 30 degrees Celsius, ice won't spontaneously convert into liquid water. So spontaneity is condition dependent. Another important point to note is that spontaneous does not mean fast. Spontaneity and speed or rate of reaction are easy things to mistakenly connect in your mind. But spontaneous processes may or may not be fast. Consider nails rusting. A nail takes quite a long time to rust completely, but it happens spontaneously. And on the other hand, acids and bases, when mixed together, neutralize each other spontaneously, and it happens extremely quickly. So, there's no obvious connection between spontaneity and speed of the reaction. Another thing to understand is that if a reaction is non-spontaneous, or a process is non-spontaneous, that doesn't mean that it's impossible. An easy example is that sodium chloride doesn't spontaneously convert into sodium metal and chlorine gas. So this process doesn't happen automatically, but you can make it happen if you put some effort in. Now, your textbook is going to relate spontaneity to the concept of reversible and non-reversible reactions. But in my opinion, it doesn't really go into quite enough detail to make that explanation understandable. The main thing that I'd like you to take away from that section is that reversing a spontaneous process requires energy. And when you reverse a spontaneous process, the energy that you use to reverse it moves from a concentrated form to a more diffuse form. That is, energy tends to spread out, become more diffuse. So this is a bit of an abstract concept, but imagine that you have a piston with a heavy weight on top of it, and gravity is pulling that weight down. That's happening spontaneously. If you want to reverse that process and lift the weight up, you have to have something push the piston upward. And maybe that something pushing the piston upward is a gasoline combustion engine. You're taking condensed energy, concentrated energy in the form of that gasoline, and you're burning it. And as you burn, all of that heat energy spreads out and it warms up the engine and it warms up the air around the engine, and all of the heat energy spread out over a much larger area.